Hello, today I will show you how to make simple LT317 voltage regulator circuit. This will be circuit simulation in LT Spice. The LM317 is an adjustable 3-terminal voltage regulator, capable of supplying more than 1.5 amps over output voltage range of 1.25 volts to 37 volts. It has an internal short circuit current limiting and thermal overload protection. Dropout voltage of LM317 is approximately 1.5 volts. That means that we must deliver to input pin 1.5 volts higher voltage. Minimum voltage input is 3 volts and maximal is 40 volts. It requires only 2 external resistors to set the output voltage. External input bypass capacitor is recommended and same goes for output pin. Typically 0.1 microfarad for input and 1 microfarad for output. Now let's talk about working principle of circuit. On input we have simple voltage source, in our case battery. It could be a laboratory power supply. This is an input bypass capacitor as recommended. This is LM317 chip with 3 pins. 1 input, 1 output and adjustable pin. On the output line we have 50 ohms resistor acting as load. Output capacitor is used for ripple rejection. We should be careful when using small loads or disconnect an output resistor. For good regulation, LM317 needs a minimum output load, so we must take this into account. This is formula for calculate output voltage of LM317. We can see that we can't go below 1.25 volts, because of LM317 internal voltage reference of 1.25 volts. Because current from adjustable pin is very low, typically 100 microamps, we can forget about this part of equation. But if we take resistor R2, with very big value, then it can get bigger, but still very small error is produced. For R1 I took a 240 ohm resistor. This is one of typical resistors and it is suggested in datasheet of LM317. So for 3.3 volts output voltage calculated R2, resistor value was 390 ohm. I take a 370 ohm resistor, because it is a standard value. So now we must run a simulation. And here is our 3.3 V output. And that is a current trough load. Now let's change R2 value and see the result. We will change it to 720 ohms. Output should now be at 5 volts. Let's run the simulation. Yes, we did it. As we can see, circuit is working. Now try some weird stuff. What if I want 12 volts regulated output? I will change a resistor to 2200. Let's run the simulation. Yes. Output voltage successfully predicted. Now what happens if I put battery voltage somewhere near 12 volts? Let's try and run it. Now output voltage is not even close to 12 volts. What happens? Yes, it's the dropout voltage of LM317, so be careful when designing circuit. Now put it back. And here we are. Now what if I change value R2 to 240 ohms, same as R1? Output voltage must be near 2.5 volts. Let's run the simulation. And it is. But be careful, let's see the numbers. Voltage on output is approximately 2.5 volts and voltage of source is 14 volts. Now let's make a output resistor with value of 2.5 ohm. Start the simulation. Everything is okay. But wait. On output we now have 1 amp, that is the current trough LM317. We know that it can make it trough with 1 amp, but wait, voltage drop over LM317 is approximately 12 volts. 1 amp 12 volts, that is 12 watts of power on LM317, and that is not going to work. And that is limitation of linear regulator. There are plenty of good circuit designs for LM317 on internet, so you try it. This is definitely a good project to start with. Take a datasheet and make it through. Enjoy rest of the day. Let there not be a spark with you. Goodbye.